Hi, this is Mrs. Downey, and I'm going to talk about lesson 6.5 quickly about solving square root and other radical equations. We've learned in the past that when we have something like the square root of x equal 5, to clear the square root or the radical sign, whatever the root or index is, we're going to take it to that power. So this is like a square root. We're going to take that to the power of 2. If I do it to that side, I have to do it to this side. Whatever's on this side, all of it gets squared. Okay? We had one single term here, so it just becomes 25. And the square cancels that out, and we have an x equals 25. Okay, so if I had a cube root, right? So all I have to do is look at my index, and that's what I'm going to put it to the power of on each side. And let's make it a little harder. Okay, so if I did this, I would have, that would cancel out to x equals, and then I would have the cube root of whatever 2 plus x cubed is. Okay? And so to clear it, you've got to multiply it to the power of whatever the index was. Okay, so let's look at our first problem. In our first problem, we have solving a square root equation. What's the solution of 3 plus radical 2x minus 3 equal 8? Well, you want to clear all terms but the most complex, your radical, from one side of the equal sign. So I want to keep this and get rid of the 3. Okay, so I'm going to subtract a 3 from each side. And I get leftover radical 2x minus 3 equal 5. Okay, and our next step then is to square each side to clear the radical. And I'm left with 2x minus 3 equal 25. Add 3 to each side. And I get 2x equal 28. Divide each side by 2. And I get that x is equal to 14. And that is my answer. Now, what you want to do when you finish is to check your answer. You plug it back into the original equation. So we'll just do it right here. And I'm going to plug in a 14 for x, right? So we're going to say, does 3 plus the radical of 2 times 14 minus 3 equal 8? Okay, so what we want to do next, 2 times 14 is 28. 28 minus 3 is 25. So we have radical 25. 3 plus radical 25. Does it equal 8? Excuse me. And radical 25 is 5. And 3 plus 5 is 8. And 8 does equal 8, so it checks out. So our answer is definitely x equals 14. Okay. Let's look at the next problem, another one just like it. Radical 4x plus 1 minus 5 equals 0. So we're going to start by adding 5 to each side. And we get radical 4x plus 1 equal 5. Now square each side. Okay, and then we get 4x plus 1 equal 25. Subtract 1 from each side, and we get a 24. Divide each side by 4, and we get a 6. So we have x equal 6. Okay, when we plug that answer in, we get, does the radical 4 times 6 plus 1 minus 5 equals 0. Okay, so 6 times 4 is 24, plus 1 is 25. Radical 25 is 5. 5 minus 5 is 0, and 0 does equal 0, so it checks out. So our answer is x equal 6 for sure. Okay, so there's something we need to learn before we go to the next problem. So I want to point out that when we have something to a power, it's like x to the 2/3 power, if I want to clear that out, I'm going to have to multiply it by its reciprocal. So to the 3/2, right? Because 2 times 3 is 6, and 3 times 2 is 6. 6 over 6 is 1. So what that does, when you multiply a power to its reciprocal, you just cancel that out, and it becomes a power of 1. And so to do this, if I multiply one side by that power, I have to multiply everything on the other side, which here is just a 2, to that same power. So this cancels out, and we're left with x on the left, and on the right we have 2 to the 3/2 power, which we learned from a previous lesson. You know, the bottom is our root, which is square root, and the top is our power, and our term is our radicand. So the square root of 2 cubed, so whatever that is, becomes our answer. So let's take a peek at our next problem. We have, what is the solution of 3 times the sum of x plus 1 all to the 2/3 power equal 12. So the first thing I'm going to do is decide what am I leaving, and I'm going to leave the most complex thing, this right here. And I'm going to get rid of everything else, so our problem becomes easier to work with. So I'm going to divide each side by 3, and I'm left with x plus 1 all to the 2/3 power equal 4. Now I'm going to multiply each side times that reciprocal of the power, 3/2, 3/2, and it cancels out, and I'm left with x plus 1 equals, and I'm going to go ahead and convert this, square root of 4 to the 3rd power. Well, square root of 4 is 2. 2 to the 3rd power is 8. So I have x plus 1 equals 8. Okay, one thing I forgot to point out a moment ago is when you are clearing out a fraction power, if either the numerator or the denominator of that power is even, for example, it was right here, okay, we had 2 is even, so when you clear it with the 3/2, you have to use the absolute value here. Okay, so anytime you have an even, either in the numerator or the denominator or both, you've got to use the absolute value when you clear. Okay, so now to clear our absolute value here, we do the positive negative of that. Okay, so we're going to end up with 2 answers, x plus 1 equal a positive 8, and x plus 1 equal a negative 8. Alright, so subtract 1 from each side, and you get x equal 7, so there's one answer, and on the other side, it's going to be x equal negative 9. Now, Okay, so for our next problem, like number 2, it says what is the solution of 3 times the 5th root of x plus 1 cubed plus 1 equal 25. So we see that our most complex thing here is this guy right there. Okay, so we want to keep him here and get rid of everything else. So the first thing I'm going to do is subtract 1 from each side. Alright, and then I have 3 times the 5th root of x plus 1 cubed equal 24. Now divide each side by 3 and I get an 8, and that clears the 3 over there. So now I have this term right here that I can rewrite as a fractional power. Now I have, sorry, oh my gosh. Okay, so now I can rewrite this as fractional power. So it's going to be x plus 1. And remember, that's the denominator, that's the numerator. So 3/5 power equal 8. Now to clear it, now notice that they're both odd, so when I clear it I don't need the absolute value signs. So I'm going to multiply times the 5/3, and then I'm going to multiply 8 to the 5/3. These cancel out, and I'm left with x plus 1, don't need the absolute value signs, equal, and now I'm going to rewrite this as a radical. So that becomes the cubed root of 8 to the 5th power. So cubed root of 8 is 2. 2 to the 5th power becomes 2 times 2 times 2 times 2 times 2. So that's 4 times 2 is 8. 16 times 2 is 32. So this becomes 32. X plus 1 equal 32. Subtract 1 from each side, and I get that x equals 31. Okay, and I would plug this back in and check to see that I got a correct answer. And let's pause. So I went ahead and checked this, and I plugged in 32, and when I did, it went all the way down. Our answer checks out. So our answer was 31. Okay, our next problem is a word problem, and it says for a meteor crater in Arizona, the formula D equals 2 times, I'm going to write this as we go, 2 times the cubic root of V over 0.3 relates the diameter D, so this is our diameter, of the rim in meters and the volume V in cubic meters. And we're talking about the giant crater in Arizona where a meteor hit and blew all the dirt out. It's a giant crater. So we're looking for the volume that this huge crater can hold. They've given us the diameter. In our picture that we had, the diameter was equal to 1.2 kilometers. Okay, and we need, it says the diameter is in meters, so the first thing we need to do is convert the 1.2 kilometers to meters. So we're going to multiply times 1,000, and we get 1,200. Okay, so now that's our diameter. So we're going to replace diameter with 1,200 and keep solving for the volume. So 2 times the cubic root of the volume divided by 0.3. So the next thing we need to do is clear this cubic, well actually let's get rid of the 2, divide each side by 2, and we get 600 equals the cubic root of the volume divided by 0.3. And our next step is to clear this cube, so cube both sides. And that goes away, and we're left with the volume divided by 0.3 equals the cubic root of 600. All right, and now multiply both sides by 0.3, and that clears that, and that's our answer. So the volume is equal to 0.3 times 600 cubed, which comes out to approximately 64,800,000. Okay, so, and that would be in terms of meters cubed. And that's our answer. Actually, that's exact, it's not approximate. Okay, our next problem is problem 4, checking for extraneous solutions. Extraneous solutions are when you solve something, you get down to an answer like x equal 2 or x equal -3. And then when you plug them both back into the original equation, and let's say one comes out true and one comes out false. When they come out false, and they both could come back false, and they could both come back true. But in any case, when you plug one of your solutions into the original equation and it comes back false statement, then you call that an extraneous solution. Okay? So we have to check all of our work in this lesson, and if it comes out false, we don't include that in our solution set. We say that's an extraneous solution. So let's check. What's the solution of radical x plus 7 minus 5 equal x? So this we want to keep on this side of the equation, and let's get rid of the 5. So add 5 to each side, and that clears. And now to clear our radical sign, we're going to square each side. All right, and that clears this, and we're left with x plus 7 on the left. And on the right, we've got a binomial squared, and we learned in algebra if we have a plus b squared, it's equal to a squared plus 2ab plus b squared. So let's do it. So a squared plus 2ab plus b squared, right? So my a is x and my b is 5. So we're going to have x squared plus, now multiply them together and double it. So 5x doubled is 10x, and my last term squared is 25. Okay, now let's get everything on one side of the equation. So subtract 7 from each side, and we're left with an 18. And then subtract x from each side, and that leaves us with a 9x. So we're left with 0 equals x squared plus 9x plus 18. Now that we can factor into x plus 3 times x plus 6. So that means that x is either equal to -3 or x is equal to -6. So when you plug these back in to check, okay, so I've written both of these down, and when you plug in -3 for x, it comes out true. So -3 is a solution, but when you plug in our -6 into the original solution and solve, you end up with -4 equals -6, which is not true. So this is an extraneous solution. So extraneous solution, and this is, yes, a solution. So our answer is -3. Okay, our last problem is what is the solution of radical 2x plus 1 minus radical x equal 1? So you want to keep the most complex term isolated. So that means I'm going to add radical x to each side and get rid of that. Okay, that leaves us with radical 2x plus 1 equals radical x plus 1. So my next step is to clear the radical sign. So I'm going to square each side. And that leaves me with 2x plus 1 equals, and now I'm going to do my binomial squared formula. So radical x squared is x, and then plus 2 radical x plus 1. And that is just the a squared plus 2ab plus b squared, right? And that's my a and that's my b. That's how I got this. Okay, now I'm going to start clearing everything to one side. And so when I subtract 1 from each side, those go away. And then I have 2 times radical x. Oh, I've got an x, subtract x from each side, and so I have x equals 2 radical x. And now divide each side by 2. Alright, and now square each side to get rid of that radical. Alright, so this becomes x equals x squared over 4. And actually, I'm going to put all this, take it all out of fraction form. So I'm going to multiply each side by 4. And I have x squared equals 4x. So now I'm going to subtract this 4x from each side. And it leaves me with x squared minus 4x equals 0. And now I can factor out an x right here.
Dean, Benny, can you please come to the main office?
And now I can answer. So what makes this true is when this x is equal to 0 or when x is equal to a positive 4. Now plug both of those answers back in to see which one is true, and maybe they're both true. So 0 and 4. So when you plug both 0 and 4 back into the original equation, they both check out to be true, so they are both solutions. And that's it. Thank you for watching.